All right, guys, here we go. This is 4.4 part 1. We are talking about trig functions now of any angle, okay? Before we talked about trig functions that were on the unit circle. Remember, I gave you an angle on the unit circle, and I said, what's the sine, what's the cosine, what's the tangent, and all that. And you could tell me that from the ordered pair. So today, we're going to talk about trig functions of any angle, not necessarily something that's on the unit circle. We're not going to give you an angle value. What we're going to give you is an x and a y. Okay, so what you guys have to take away from this, especially this first part today, is we have to remember how to find our r, which is just our hypotenuse of a triangle, and how to, or where the signs are in each quadrant. That's going to be a major thing. But if you're looking at this, does this formula remind you of anything?
Yes.
What?
C.
Right? Is that not the same thing as a squared plus b squared equals c squared?
Mm-hmm.
Right? Because what would you do to find c? You take the square root of a plus b, right? So, okay, same exact thing. You're using the Pythagorean Theorem here. Instead of saying what's the c value, the hypotenuse, you're going to find the r value. That's all that this is. So if you notice, what's going to happen is they're going to give you an x and a y value, an actual value, a number, not 1/2 or root 3 over 2. They're going to tell you x is 7 and y is -4. You're going to find the r, which is going to be your hypotenuse, and then you're going to find the trig functions. What the trig functions are, guys, in our ordered pair, when I gave you an ordered pair, it was 1, 0. Sine was our y value, right? So all this is your y value over your hypotenuse. Your cosine was your x value. So you take the cosine over the hypotenuse. This is the same thing as our right triangle trig, our SOHCAHTOA, that sort of a thing. But you're talking about any angle all over the trig, any angle in the world, not just something on the unit circle. So things are labeled differently. So what you're going to do is you're going to find your x value, your y value, your r value, and then you can find all the trig functions. Everybody okay with that? If you need to, take a little picture of this, put it on the next slide. That's helpful for you. We're just going to do a bunch of examples. I say a bunch. We're going to do like 3 or 4, and then that'll be it. If I said let -3, 4 be a point on the terminal side of an angle, find sine, cosine, and tangent. All right, so I know that my x value is what? What did they tell me my x value was? X is -3. What is my y value? +4. How am I going to find my r value? Okay, x squared, so -3 squared plus 4 squared equals r squared, right? What's -3 squared? 9 plus 16 equals r squared. What's 9 plus 16? 25 equals r squared. So what's my r value? 5. What do you know your r value should always be? What kind of a number? It should always be positive. Yes, you're going to be dealing here. We're not talking about side lengths. We're not talking that x is -3 units. We're talking about that x is a certain point on the coordinate plane. Your x and your y values can be negative depending upon which part of the coordinate plane they're in. If this is the second quadrant, third quadrant, something like that. But your r value should always be positive because you're squaring both of them. Does that make sense? So now that you guys have your x, your y, and your r, you can tell me what the sine, the cosine, and the tangent are. The sine of theta. Look at your little cheat sheet, whatever, that you guys just took a picture of. Is what letter over what letter? Y over r, right? Cosine theta is x over r, correct? Tangent of theta is what? Y over x. So the same thing we did with our right triangle trig, our opposite, adjacent, and hypotenuse, it's the same thing. But we're talking about points that create triangles on the coordinate plane, not about buildings and stuff like that. So your sine is going to be y over r. Your sine of theta is 4 over 5. Make sense? Cosine is what? -3 over 5. What is tangent? 4 over -3. So when you're given a picture find all 6 trig functions. You guys have done this. We've already done this a million times. What do I know in letter A? What have they already told me? What 2 values do I already know? I already know that my x value is 4. My y value is 3. Correct? Now, how do I find the r? How do I find the hypotenuse? I'm going to use the Pythagorean Theorem. 4 squared plus 3 squared equals r squared. So 16 plus 9 equals r squared. 25 equals r squared, so r equals 5. So r equals 5. Now I have all of the information I need to find all 6 of my trig functions. Sine of theta is y over r, correct? So then my cosecant of theta is what? R over y, okay? So cosine theta is x over r. So my secant theta is r over x. Perfect. My tangent of theta is y over x. So then my cotangent is x over y. And now can we fill all the information in? Yeah. What's your sine? 3 over 5. So what's my cosecant? 5 over 3. Good. My cosine is 4 over 5. So what is my secant? 5 over 4. Good. My tangent is 3 over 4. So my cotangent is perfect. Questions? Where do you notice that the point that they gave us, the point on the terminal side of the angle, where is it in letter B? It's in the second quadrant. So in the second quadrant, you should think, okay, what are the values of my x and y? In the second quadrant, your x value is what kind of a number? Negative. Your y value is positive. So now we have to find out what r is, or our hypotenuse. So I would just say negative 8 squared plus 15 squared equals r squared. Remember, when you square a negative number, it becomes what? Positive. If you put negative 8 in your calculator and square it, but you don't put it in parentheses, it'll tell you it's negative 64. So just make sure you put it in correctly. But negative 8 squared is 64 plus 15 squared is 225 equals r squared. What's 64 and 225? 289? Okay, so 289 equals r squared. Well, what's the square root of 289? 17. Are they all going to turn out to be nice, beautiful whole numbers? Absolutely not. Why would we do that, sillies? So sine of theta, remind yourself, is y over r. So cosecant of theta is r over y, correct? Cosine theta is x over r. So secant theta is r over x. Tangent theta is y over x. Cotangent theta is x over y, correct? All right, so tell me, what's the sine? Sine is 15 over 17, agreed? Okay, so what's our cosecant? 17 over 15, good. So cosine? Negative 8 over 17, so then secant is 17 over negative 8. Does it matter where you put that negative? No. It can be in the denominator, it can be in the numerator, or it can just be out in front. Doesn't matter. And then my tangent is y over x. 15 over negative 8. And negative 8 over 15. Good job, guys. Okay. The point on the terminal side of an angle in standard position determine the exact values of the 6 trig functions of the angle. How is this a teeny bit different? I don't have a picture. Do I really need one? No. All right, what is negative 4? My x value. What is 7? My y value. So over here, I'm going to write x equals negative 4, and I'm going to write y equals 7. I like to write it out like that, away from the ordered pair, so I don't make mistakes. So how do I find my r? Okay, so negative 4 squared plus 7 squared equals r squared. 16 plus 49 equals r squared. What's 16 plus 49? 65 equals r squared. And then how do I find just r? Square root. Can I break down 65?
No.
65 divided by 5 is 13. That's not going to help us any. So r is the square root of 65. It's the square root of 65. If you had to have a mental picture, where is this point, negative 4, 7? It's over here in the second quadrant, right? So your angle is something like this. All right, no biggie. But it's in the second quadrant. So now that you have your x, y, and r values, you can find all 6 trig functions. Sine, write yourself a little nose, y over r. Cosine of theta is x over r. Tangent of theta is y over x, correct? Yes? So our cosecant of theta is r over y. Our secant of theta is r over x. And cotangent theta is x over y. Are we going to have to rationalize? Yes, that's okay. Sine is y over r. So it's 7 over the square root of 65. Can I leave square root of 65? So we rationalize. And I have 7 square root 65 over 65, correct? Okay. If you want to move over and do cosecant, that's fine. Cosecant's going to be r over y. So it's the square root of 65 over 7. That's it. X over r. So negative 4 over the square root of 65. Can I leave the square root of 65? Rationalize, we get negative 4 root 65 over 65. R over x is going to give me the square root of 65 over what? Negative 4. Good. And then my tangent and cotangent, y over x. So 7 over negative 4 and negative 4 over 7. Good. Scoot on over. 3, negative 4. Well, what is 3? X. What is negative 4? Y. So x equals 3, y equals negative 4, and r equals what? We got to find it out. But think about this. Where is this angle? It's over here in the fourth quadrant. So it came around like this. But again, you guys should be able to visualize that. You're going to need to be able to visualize that a little later. But if I have 3 squared plus negative 4 squared equals r squared. 3 squared is 9. Negative 4 squared is 16 equals r squared. What's 9 and 16? 25 equals r squared. What's r equal, guys? 5. This is a nice pretty one. So I have sine theta y over r. Cosine theta x over r. Tangent theta y over x. Right? Cosecant theta r over y. Secant theta r over x. And cotangent theta x over y. Yeah? All right. So y over r. Negative 4 fifths. All right. So what's my cosecant? 5 over negative 4. Okay, good. What about cosine? 3 over 5. So what's my secant? 5 over 3. Good. Tangent, y over x. So negative 4 over 3. So what's my cotangent? Negative 3 over 4.